for least common multiple, page 250 in your book. So let me get my pen going here. Page 250. You need to make sure that you're following along in the book. Sometimes I point out some important things, and there's some important examples, so please follow along. The vocabulary is multiple, and multiple is defined right on the first page there, 250. It says a multiple of a number is the product of the number and any non-zero number. So multiple is kind of like multiply. It's when you take a number and multiply it by 1, 2, 3, 3, and so on. Another way to look at multiples is like counting by that number. And I'll do an example here to show you, okay? So let's say I want the multiples of 3. Okay, so the multiples of 3, if we do the first thing I said, you just take it. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And so on. Okay? Or you can just count by threes. My pen is, it's not, 3, 6, 9, 12, and so on. Those are multiple. And I remember multiple is the first part of multiply, so the numbers have to get bigger. Sometimes people get factors and multiples mixed up. Okay? Common multiple is when you have 2 or more numbers. You want to find their common multiples. So let's do 3 and 7. So you would write the multiples of 3, which would be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on. And then you write the multiples of 7, 7, 21, 28, 35, and so on. And right now we can stop. We found one common multiple. They both have 21. So 21 is a multiple of 3 and a multiple of 7. So those are called common multiples. Now I could get more common multiples. I could keep going. That would be 42, let's see, 33, 36, 39, and then 42. So 42 would be another common multiple. And sometimes problems will say, what are the first 3 common multiples? Or if something happens every 3 seconds and every 7 seconds, when will they happen at the same time? After 21 seconds, after 42 seconds. Those are some interesting, some real life situations where that happens. Least common multiple, I'm going to go ahead and leave this example up here. Least common multiple, LCM, is obviously the smallest common multiple of 2 or more numbers, because you could have a third number in here. So my LCM for this problem is 21. That's the least common multiple. And sometimes we use those when we're adding fractions. We want to find the least, we call it denominator, but it's still the same thing. So let's do some of these. Example 1, you can use common multiples to answer the question about ferry boats. Begin by writing the multiples of 25 and 30. Then identify common multiples through 300. Well, let's read that problem. There is a problem at the top of the page on 250. It says 2 ferry boats leave a landing platform at the same time. One of the ferry boats returns to the loading platform every 25 minutes, the other one every 30 minutes. In the next 300 minutes, when will they return at the same time? So they're asking you for how many times will these numbers match up? So we got to go to 300. So I'm going to list them. 25s are easy because I count by quarters. 25, 50, 75, $1, $1.25, oops, $1.50, $1.75, 200, 225, 250, 275, and 300. 30, 30, 60, 90, 120, 150. We're just adding 30 each time. 210, 240, 270, 300. All right, so when will they be in there together? We've got to find numbers that match at 150 minutes. That'll be the first time they come in together. And looks like 300, huh? Identify the common multiples through 300. So I am getting 150. After 150 minutes, they'll both be back, and after 300. And they're doing the same thing we just did, the common multiples, so there's our answers. So in the guided practice, find two common multiples of the number. Two of them. That's important right here in the instructions. So 2 and 3, and I usually just write them on top of each other, and I just start going by twos. 2, 4, 6, 8, 10, 12. And you do about 4, 5, 6 of them, then go to the next number. 3, 6, there's one that matches. 9, 12. So there's my first common multiple, there's my second common multiple. So the two common multiples are 6 and 12. There we go. 3 and 5. So we do the same thing. 3, 6, 9, 12, 15. And I know that's 1 because let's just catch up the 5s. 5, 10, 15. Now let's see, let's keep going. 18, 21, 24, 27, 30. So this one's going to be 20, 25, 30. So it's going to be 15 and 30 are my common multiples. 8 and 10, and I know sometimes it's easy to tell what they are. It's just nice to practice the multiples, kind of help us practice our facts. See if I can count by 8s. 8, 16, 24, 32, 40. There's one of them. 48, 56, 64, 72, and 80. And so for 10, 10, 20, 30, 40, 50, 60, 70, 80. And I also need to remind you guys that you need to write out the guided practice, not just the answers. Please write out the problems with me. So you're doing all of these, the 8th and the 10 with me. All right, 6 and 18, common multiples. So 6, 12, 18, 24, 30, 36, and I think that's enough. Look, there's the first one, 18 and 36. Yay, that one was pretty easy. All right, the last guided practice, it says a cuckoo clock has birds that pop out of their nests every 6 minutes and dancers that pop out every 15 minutes. The birds and dancers have just popped out at the same time. When will this happen again in the next 60 minutes? So they want to know what is the least common multiple of 6 and 15. So when is it going to happen again? 6, 12, 18, 24, 30. And if you're thinking about the other number, you can see that 30 is the one. So after 30 minutes, they'll pop out again. Every 30 minutes, actually, they will pop out. So if they popped out, when will it happen again in the next 60 minutes? It will happen at 30 minutes, and it will happen again in another 30. 60 is 230, so it'll happen twice. All right, now here's the key concept box on the top of page 251. So you need to look at this just like there's 2 ways to find the greatest common factor. There's 2 ways to find the least common multiple. Now, finding the least common multiple or 2 or more numbers is the smallest of the common multiples. Below are the 2 methods to find the LCM. Okay, so method number 1 is what we've been doing. We have been listing the multiples of each number, then we find the common multiples. That's what we've been doing in example 1 and in all of the guided practice so far, okay? But method 2, this is the new one right here. All right, method 2, which we will practice, okay? Method number 2 is write the prime factorization of the numbers, which is the trees, multiply together the prime factors, use each prime factor the greatest number of times it is a factor of any of the numbers. Now that's really confusing with words, but go ahead and write it down in your notes, and then when we'll get to this example and we'll do it that way, and I'll show you guys how to do it. So it says using multiples, find the LCM of 9 and 12. I'm going to do it both ways. We just talked about 2 ways to do it, so let's do it by listing first. This is method number 1, which we've been doing. Okay, so 9 would be 9, 18, 27, 36. And I'm going to stop because I know 12 goes into 36. 12, 24, 36. So my least common multiple of 9 and 12 is 36. And that's a great method when the numbers are small like that. I don't have any problem with that method when the numbers are small. But let's practice this other method with those same numbers. So the first thing, if I go back to, it says write the prime factorization of the numbers. Okay, so that's the first thing we do is we do the trees. 9 is 3 times 3, and those are prime, so we stop. 12 is 2 times 6, 6 is 2 times 3, done, so I stop. Now, here is the key for this one. It's very important. When you write your prime factorizations, you need to write them with exponents. So 3 times 3 is written 3 squared for 9. 12 is 2 times 3 squared. So, sorry, it's not 2 times 3 squared. It's 2 squared times 3. Okay? Now what I do is I write them, the two answers, on top of each other, lining up the same prime factors. So they don't have, this one doesn't have a 2, so I don't worry about it. The 3's, I line them up. What you do is you pick the biggest of each prime factor in these answers. So this one is the biggest because it's the only one, the 2 squared, so you circle it. Then you have a 3 and a 3 squared. The 3 squared is the biggest, so you circle it. You take the numbers you circled and multiply them. So 2 squared is 4, 3 squared is 9, 4 times 9 is 36. So this method works great when you have huge numbers, because I've had problems where you'd have to find the multiples and you have to write them out and it gets into the thousands. Well, it takes forever to list them. This way it takes very little time. Once you get the trees done, it takes very little time. And we'll practice these with you. I'll do some examples. So here they are listing their multiples. Okay? And then here they are also, oh, that was just them doing, they did that one just with multiples. But I wanted to show you an easy one with the prime factorization. Okay, so 42 and 60. Now, here's the deal with 42 and 60 is you do the trees. So you just take 42 and break it down. That's 6 times 7. 7 is prime. I circle it. 2 times 3. That's as far as you can go. 60 breaks down. I'm going to use 6 and 10. 6 is 2 times 3. Done with that one. 10 is 2 times 5. Done with that one. So I write 42 as 2 times 3 times 7. This one is 2 squared times 3 times 5. And if you take them and line them up, 2 times 3, and put the 7 out there so we have room for the 5. So when you line them up, you pick the biggest. So 2 squared is the biggest, so you circle it. Now this one's a little tricky. When there's a tie, I call it a tie, because that's just a sports thing, I guess. I call it a tie, so you pick one of them. So you just circle one of them. Neither one is bigger than the other, so you just take one of them. And if there's only one number like the 5, it's obviously the biggest, and there's only one 7, so you circle it. Now I like to circle when they're in the same. I know that's equal to 60 because that's what we got up here, and so it would be 60 times 7, which is what's left, is 420. Now you could list them out until you reached 420, or you can do it this way. And the trick is, what do you circle? And then remember at the end, after I circled all those, all I did was multiply these together. That's 4 times 3 times 5 times 7, which comes out to be 420. And so they're doing the same thing. They're circling theirs. They do it a little bit different than I do. They look at how they write those out. I think that is a little confusing. I think it's easier the way if you write them with exponents. Okay? So it's important now to read the directions, because sometimes it will say you can list them, and other times it will say you have to use prime factorization. So this one by listing, 6 and 8. So we take 6 and 8 and we list 6, 12, 18, 24, and I'm going to stop 8, 16, 24. It really helps to know your facts to know that which numbers those go into. 5 and 9 we're still listing. 5, 10, 15, 20, 25, 30, 35, 40, and I believe I can stop at 45 if you guys know your 9s. 9, 18, 27, 36, 45. So my LCM is 45. 9 and 15, 9, 18, 27, 36, 15 is 15, 30, and 45. Look there again, 45. Okay, now it says use prime factorization. So we take the 8, we break it down, 2 times 4, 4 is 2 times 2. So I'm done with those. So that's written 2 to the third. 12, let's do 3 times 4, 4 is 2 times 2, so that's going to be 2 squared times 3. Now let's write those on top of each other. Circle the biggest 2 is the 2 to the third, the biggest 3 is the only 3. Now we multiply those. 2 to the third is 8, not 6, because it's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 8 times 3 is 24. And even if you know, if they say use prime factorization, you can't get good at it if you don't practice it. So is that the one? Oh, that's one we just did. All right, 8 and 14. So we already know 8. 8 was 2 to the third. We just did it. 14 is 2 times 7, so we'll pile those on top of each other. The biggest 2 is that one. There's only one 7. So 8 times 7 is 56. That's my LCM. There it is. 50 and 90. I'm going to take a guess that it's, oh, I don't know. Well, I don't know. How about this? 5 times 10, 2 times 5. So that's going to be 2 times 5 squared. 9 times 10, 3 times 3, 2 times 5, so that's 2 times 3 squared times 5. Alright, so let's do some piling. 2's on top of each other. There's a 3 squared times 5, and we'll put that 5 squared there. There's a tie, so I circle one of them. There's only one 3, so I circle it, and there's one, or the 5 squared is bigger. So that's 9. Times 2 is 18, and 5 times 5 is 20. 18 times 25, 450. Or we could have written them out till we got to 450, but prime factorization is supposed to make it easier. So that's using prime factorization. If you do not understand how to do that, please see me so I can show you. I will try to do some on the board when everybody gets there. Talk to you later.